Good morning, everyone. Um, we're going to wait for your friends. Yeah, we're just going to wait for about 5 minutes. Yeah, 5 minutes. Then we'll start our lesson.
Jacob,
Yes.
first, good morning.
Morning. How are you?
I'm okay. Do you have is that slide nearby the one you are using last time? While we were coming up with the formula for the pi r squared and 2 pi r.
Which slide? Which slide?
The example you gave us last time. How we came up with the 2 pi r and the 2 pi r.
Yeah. It's near. Yeah. You wanted.
While waiting for before we start, I was asking if you can just pass through it. I was trying passing through it. I was finding it hard to understand how we got there.
Oh, okay. Let me just put it.
All right.
I hope you can see my sharing. Hello.
Yes. Yes, I
Oh,
can see.
okay. You meant for this one, where it gives you pi r squared.
Yes.
So you want me to explain how you come about it or what?
Yes, like how you come about it. Like here we're integrating like for if you look at this formula here, we're saying rho, d rho, then d
Theta.
d theta. Yeah.
Yeah.
So like that arrangement there, is it okay if like it was like the other one, like the first one that we had, is it the same as d rho, then rho d theta?
Yeah, it's the same. It's the same. Here is they are just what they are like when you start to differentiate, you just group the like term together. Like the rho and d rho, they are like they consider them to be like terms because rho and d rho, they are talking about radius, both of them. Yeah, so rho is a radius which is constant, and d rho is the radius which is changing. If you check your diagram here, uh, as I said earlier, like when you are doing the coordinate polaire, I said that for you, for example, if this is m and this is m prime, for you to reach your m prime, which is at this corner, you have to move first this arc, and when you move this arc, you see that the radius will still remain what the same, which is the rho. Then for you to have the M prime, you have to move like you're moving outside, meaning you change the radius, which is what the zero. So basically, it's if you see that equation of displacement M prime, you have d rho times vector e rho plus rho times d theta. Then when you're calculating the surface, you should always know that you group the like terms together, like those which I can say in simpler terms, those which say the which signify the same things. So we see rho and d rho, they both talk about what? Radius. So you mean it means this the what the you won't write rho d theta, you write rho d rho in terms of when you're finding the surface or the volume, which is both of them they are talking about radius, meaning you have to want to integrate it in terms of rho d rho, then d theta is on its own. Then
All right.
yeah.
So like here the D row. Did you integrate it here? Because I'm only seeing the row being integrated here. How about the D row? Is it going to
So
be maybe it's just going to be 0?
yeah, so here I'm integrating the rho parable in terms of the rho. Here, what it means is when you see the rho, it means I should integrate this one, the rho, which is here. I should integrate it in terms of what the rho, which means that what I'll only like I only integrate this one in terms of what the rho. For example, for d theta, imagine there's d theta, then here is just the same as you have one. You know that one times anything, it will give you the same thing. So here you have one. So it means your one, which is here, you integrate it in terms of what? D theta. And when you integrate your one, it will become what? Theta. And when you integrate your rho, it will become rho squared. Meaning, you know that formula n plus one, like most is, when you're integrating something, it is, if you're given in terms of x, it will be x, for example, for x is equal to, I can say x is equal to n plus 1. So it depends what you are given. If you are given, I can say uh, uh, a constant meaning a number. If you are just given a number, it means your n is 0. You don't have n variable, I can say n variable. Yeah, your what? Your n is 0, so it will be 1 to the power 0 plus 1, which will give you just the theta. If you check your if you watch some videos on integrals, you understand better. Then for rho, you know that it's just to the power 1, so it will be 1 plus 1. It will give you rho squared over what? 2. So I don't know if it's clear. Then you just replace by r and the 2 pi. So basically, you integrate rho in terms of d rho, and here imagine there's like there's a 1 because there's a constant here because there's no what, how can I say it? There's no variable here, so it means there's what, there's a constant here. Variables, when I say variables, you know that in your mathematics we talk about the x, the y, and the x, the y, and when I talk about constant, you know that we talk about the actual numbers 1, 2, 3. So you can have for example, you can have 2x plus 2x squared plus x plus 2. So you see that 2 is the constant, then x squared and x, those they are what, they are variables, I can say so. So for it's just the same thing here. Rho is playing in I can say is playing in a place of x, just the same as x, like it's a variable. Then here you have just the same as 1, which is a constant. Then you do your integration, then you have your theta and your rho squared. I don't know if it's clear.
Right, it's clear.
So basically, like for integrals, just try watching some videos, they explain better. Even if you go like videos with you just videos how to integrate x dx, you see how they integrate x dx, because x dx is just the same as rho d rho, just the same thing. Then how to integrate dx, just dx. You see how they integrate dx. Then the integration of dx, the integration usually doesn't change. It's just the same of how to integrate what d theta. So just try to watch some YouTube videos to understand more.
All right, thank you.
Are you able to see my sharing? Hello?
Yes.
Okay, okay. Yeah, so today we're going to do a bit fast. I'm just going to talk about, yeah, we're just going to talk fast. We're going to finish very fast. Then we have to start a new topic today because like we are really behind. On Wednesday, I never had the class. There was, I don't know, there was something which was happening at the doing for certificates. So since, yeah, so I've decided that we'll have class today. That's on Monday. Tomorrow, on Wednesday, not tomorrow, on Wednesday and on Friday morning. Since on Friday morning, you are not usually you don't have any classes. Yeah, I want to cancel for Sunday. Since Sunday, a lot of you guys were busy. Some you'll be going to church, and yeah, and I believe weekends are made for you guys to rest. So yeah, so we're going to continue with our coordinate spheric. I'm just going to just do a quick repair. Yeah, I'm just going to do some I can say some summary about the things which we did last time. Yeah, I know I didn't send you the video, the last video, because it was cutting and yeah, the recording wasn't really good. So I'll just pass through this one. This one is the one which is going to cover the things which we did in the last video, so that you have all the things. So yeah, so I'm just yeah, do a quick rappel. So before we begin, I'm going to pray. Shall we pray? Our dear Heavenly Father, we come before the throne. Oh God, asking you to be with us as we start with our lesson. And I'm asking you to open my mind and impact wisdom into me, oh God, and also impact understanding into my students, oh God. In the name of Jesus, I pray. Amen. So we are going to continue. Yes.
Just a quick question. What time on Friday is the lesson?
On Friday, we'll be having it in the morning, the time for analysis, where when you use, yeah, the time where I used to have analysis.
Wait.
Yeah, that's when we'll be having it. Yeah. So we're going to just pass through fast. So we talked about the coordinate spheric, and if you remember, I said coordinate spheric. The only difference between coordinate spheric and cylindric is For coordinate-spheric, it's defined by r. Theta is defined by a radius in simpler terms, and the two angles. So r is the radius, then the two angles we have got theta and the phi, others they call it psi. So when we talk about coordinate, yeah, so I'm going to continue. So I said that when we talk about coordinate spheric, you should always know that coordinate spheric is defined by three things, which is two angles, which is theta and the phi, and the radius, which is what, r. So the only difference between coordinate spheric, so for you to really understand the coordinate spheric and coordinate cylindric, you have to know the differences between these two coordinates. So what's the difference between coordinate spheric and coordinate cylindric? So the only difference between coordinate spheric and coordinate cylindric is that for coordinate cylindric, you have what? You have it's defined by three things also. Yeah, it's defined by rho and theta and also the z. So the only difference is that there's only one angle for cylindric, and it's defined by a z, which is a z, because rho is also found on spheric, rho, which is the radius, and the theta, the angle, is also found on what is spheric. But the only difference is that uh the angle on what on when you talk about the theta, the angle theta on what on this one, you should get it. When you talk about the angle theta on what on cylindric, yeah, when you talk about the angle theta on cylindric, we talk about the angle which is made 360, which is made the angle which is made what between x and the y. So this angle is called what, the angle theta. This is for the diagram for cylindric. So this angle makes a 360 turn. It makes a 360 turn. But when we talk about the angle theta on spheric, this one you have to get it. So when you talk about the angle theta on spheric, if you see where the angle theta on spheric is here between z and y, and this angle, the angle theta on spheric, it makes a what, a 180 degrees. That's the difference. So the angle theta on spheric, on cylindric, it makes a 360 degrees. Then the angle theta on what, on spheric, it makes 180 degrees. Then the angle phi, the angle phi on spheric is the one which behaves as the angle theta on what, cylindric. So basically, most of the time, most of the people, they confuse this because they think the theta in spheric and the theta in cylindric is the same, but in the actual sense, they are not the same. So these symbols, theta, phi, what, don't let them to confuse you. They are just there to present, I can say, angles. They are just there to present angles, and they have no much significance, I can say. So like that, for example, when I say they have not much significance, I mean that it's not the case always that the theta must always be 360. It depends which figure or which form are you dealing with. So when you're dealing with cylindric, you should put in mind that the theta is between 0 and the 2 pi, which is 2 pi is 360. When you're doing those who answered the exercise which I gave them, they can relate and they can understand it very well. So you see that when you're given to find the form of cylindric, you see that when you are doing integration, where there's theta, you have to put the distances between 0 and 2 theta, 2 pi, which 2 pi, which means 360 degrees. Then on spheric, when you're doing your integration, those who did the under spheric, they understand this one. When you're doing your integration, it will be, yeah, but it's something simple. Yeah. So when you're doing integration, it will be what, 0 to to what to pi for theta, which is 180 degrees, 0 to pi, which is 180 degrees, 180 degrees, making a 180 degrees. And I think, yeah, I think that's the difference which you should note. So the difference which you should note between cylindric and the spheric is that the cylindric, the theta, it makes 360 tan, and the spheric, the theta, it makes 180 tan, which is pi, and 360 tan, which is 2 pi for what? For cylindric. Then the one which behaves as the theta on spheric, you should know that is the phi. The phi, the psi, this symbol here is the one which is which behaves as the theta in cylindric, because which behave as the same as the theta, because it also makes a what? A 360 what? Tan. It also makes a what? A 360 tan. So spheric is defined by r, theta, and the phi. That's what defines spheric for you to have a point. So basically, you for you to get what I mean, for you to get this point M, it means you have to move to open at a certain angle, which is phi, and this certain angle you have to yeah, for you to find the point M, you have to open at the certain angle, which is phi, and also at a certain angle, which is theta, and move at a certain radius, which is what? OM. These are the things which define spheric. So when you hear about spheric, you should know that we are talking about r, theta, and phi. Yeah. So now also the other thing which you have to note on spheric is that when it comes to calculating OM, the distance OM, how do you calculate the vector OM? So when it comes to calculate the vector OM, you should know that the vector OM is always equals to what? To R. R, which is the radius. Why is it equals to the radius? What you should know is that, for example, like just imagine you have this point M. So this circle here, which is in the I'm not a geographer, so I can be misplacing the word. So this circle, which is I know in geography, those who did geography, there's equatorial and the meridian. Equatorial is the plan equatorial is represented by this small circle, which is up here. Which if you imagine the how the Earth is, the circle part of the Earth, the Earth is like a sphere. Yeah, so you see that there's a plan equatorial and a plan meridian, which usually cuts I can say laterally of the Earth, and you see that you see that just do some imagination. The point here, imagine there's a Z here. This is the point Z here. Then there's a point here, which is the center of this small circle here. And this center, you have the radius, which is, let's call this center to be J, and the radius to be M. This point is M. Then let's call the let's imagine there's a point J here. So if you draw a line here, it will form what? A radius, which is JM. If you imagine, it will form a radius, which is what? JM. So it means that when I'm moving this point around this circle, which is forming a plan equatorial, you see that the point M, it will always have the same radius. And we say that when the radius doesn't change, it means your angle is a what? A constant, and it means your theta will be equals to what? To 0. That's why you see that this your phi is equal to 0, since this distance, if you see this distance OM, and the small m, if I draw it here, most of the time the distance is what is the same. I'll just get, if you try to get this distance OM and draw a parallel distance here, you'll find that it will give you exactly at what? At M. So this distance basically at OM is equal to the distance JM, because because it's just like the way the Earth is. You have the meridian, the line meridian, there's a planned meridian which is formed by if you continue this arc, if you continue this arc coming down, you see that it will form like something like a sphere which is in form of lateral sphere. Then you see that here is the base. Imagine this is the base of the Earth, and you know that the base of the Earth and the base of the earth and also the top of the earth, they have got the same radius, or the same size. So you see that this circle which is here on top is also is also the same size of the circle which you can find here down. So the only difference is that they never draw a circle here down on OM, but basically we are supposed to have a circle down here on OM, and you see that OM, the distance OM is just the equal with the distance which you have formed JM. So what I'm trying to explain is when I'm moving this point M here, I'll be changing the what? The phi. And we said that the distance JM, the distance JM, the grand M, the what? The capital M, you see that there's no difference in radius as the point moves around this circle, the equatorial the circle which makes the equatorial plane. You see that there's no actually difference in the radius, so it's constant. That's why you see that this phi will be what? Will be 0. Then for what? For theta, it's the angle which is made when you move lateral, when you're moving lateral. So you see that when I'm moving, this is OM, the point OM. When it's moving like in the sideways, you see that the distance R will also never change. It will always be the same. So the theta also is equal to 0, which only remains, which I can say will only remain with what? With the R. You know that when you move R outside this direction ER, you see that there will be somehow a change in radius. Therefore, if you are calculating the vectors, most of the time they use OM is equal to what? To R. And yeah, and you should also, you should here they're just talking about this distance OM is equal is R, and also the angle is made between OZ and what? And OI, OZ and OM, which is theta. Yeah, the angle. Yeah, the angle theta is between OZ and OM. So I've explained about this. And the angle phi is between OX and the O small m. This is small m, is not capital M. Yeah, so you make it a phi. So basically, yeah, that's it about spheric. It's defined by radius, theta, and the phi. And what you should know that when a point is moving, just changing the phi, the radius doesn't change literally, like the radius doesn't change. And when the radius doesn't change, it means your phi is equal to 0, it's constant. That's the principle which you should have. Then if I'm moving under the meridian, like the meridian plan, you see that the radius also doesn't change, so it gives me theta to be what? To be 0. Yeah, theta 0. So we want to remain with R, which has a significance. So when they ask you name the coordinates of coordinate, cite the coordinates of coordinate spheric. So the coordinates of coordinate spheric is R, theta, and phi. But when they say name the composite is what defines this coordinate spheric. What defines it? What changes it if I try changing? For example, if I try changing the angle, is there any change? If I try changing the angle, is there any change? You see that there's no change in OM. And if I try changing the radius, is there any change? You see that there's a change. So the composite, it means things which affect the coordinate spheric. If I change that thing, is it going to affect the coordinate spheric? So the composite is only R. So if I tell you, give me the composite of what of coordinates spherical, you know that there's only one composite, which is R. But if I say coordinates, the coordinates are things which defines the coordinates spherical for you to have a point, which is R, theta, and phi. I don't know if there's any question here.
I have a question.
Yeah, you can ask.
What did you say phi is equal to again?
I said phi is equal to theta, which is under spheric. If you see here, I'll go under what? I'll go for a diagram of spheric. Yeah, if you see the diagram, this is a diagram of spheric. You have seen that the diagram of spheric, there's a theta here, which is between, which is made between the angle OX and angle what? OM. This is the theta which is made OX and what? OM. Then if you go to a spheric, you will see that there's a phi here. The phi here is made between OX and also OM. So you see that the angle is just the same. They have just I can say they have just changed the variable, but it has the same what meaning. Then the theta is not, the theta we under spheric is not equal to the theta under cylindric, because the theta under spheric is only makes what 180 degrees. I don't know if it's clear.
No, I mean the value of phi, it's what?
The value of phi is between
Yes.
0 and 360.
Okay, thank you.
Yeah, it makes a tan of 0 and 360, which is just 0 and 2 pi. 2 pi is just the same as, since we know that pi is equal to 180, so 2 pi is equal to 360. So it's 0 and 2 pi, just the same. So basically, most of the times in electricity, we don't use the degrees like 180, 360. We use pi, 2 pi, pi over 6, pi over 4. Those are the things which we use to present the angles. So so you have to get familiar with it. When I say 2 pi, you should know that I'm talking about 360. When I say pi, you should know that I'm talking about the angle 180. So this theta, it only makes the angle which is 0 and pi, and the phi, it makes the angle which is 0 and what? 2 pi. Yeah, I don't know if it's clear.
Yes.
Yeah, so we're going to continue. So the base loci des coordonnées. So you see here that they are saying the base loci des coordonnées sphériques est obtenu à partir de 3 vecteurs unitaires. So we've got the vector ER, E theta, and the E phi. So you have ER basically, you see, for the radius, it's a vector which gives the direction of the radius, and we have E theta. E theta, actually, this is a vector which gives the movement of a point in a what, in a, I can say in a sphere which is lateral, the Mediterranean sphere which is moving sideways. The point when it's moving sideways, its direction which it gets is theta, which is at this angle, the angle theta. Then the E phi, the vector E phi, it shows the direction of what? It shows the direction of a point around the circle which is under the equatorial plane. This circle, which is the horizontal sphere, I can say so, the horizontal sphere. So you have got three bases. Three bases. They show, when I talk about base local, you should know that I'm talking about the vectors which shows the direction of where this point is going to be moving. So if it is ER is the moving outside of the circle, a small circle, I can say it's moving like outside from one sphere to another sphere. Then the E phi is moving around the what? The circle, which is the equatorial circle on top here, and the E theta is moving under around the sphere, which is, if you continue, around the sphere. So so these are the three bases. Yeah, and here they just explain that ER, which is vector ER, est porté par le vector position OM. So the vector position OM, they're just saying OM, it carries the what? The vector ER. Then I theta est perpendiculaire à ER et dirigé dans le sens de theta croissant. So they are saying that E theta is perpendicular to ER. E theta, which is this one, E theta, is perpendicular to what? To ER. And the E theta is between 0 and what? And the 180, which is pi, which I've already talked about. And the E phi they are saying is perpendicular to ER. So E phi also is perpendicular to what? ER. And dirigé dans le sens de phi croissant, which is between 0 and the 2 pi. Yeah, between 0 and what? Sorry, I had lost my connection. Yeah, so I hope you can see my sharing. Are you able?
Yes.
Oh, okay. So yeah, so E theta, E phi I'm saying is perpendicular to AR. So this is E phi, which is perpendicular to AR, and it's between 0 and the 2 pi, which I've already talked about. I said it makes what? A 360 what? Degrees. Yeah, it turns around 360 degrees, and they are saying here that the vector position OM is equal to RER, and I've explained and I've justified why they only use the radius, because these angles, they're always constant when a point is moving. For example, around this circle, you see that the radius JM, which I've talked, it's always the same when it's moving around the circle, which is lateral. We see that the radius OM is the same, and we know that the angle theta is constant. So you only remain with what? R, which is a component. So when you're finding the position OM, it's always R, ER, the radius which you have been what? Given. And this R is between 0 and the positive infinity, meaning it can be any number, any positive number, which is between 0 and the positive infinity. And I remember there was someone who had asked me a question like, can you find your R negative? So your R basically, if you find your R to be negative, you have to this is a kind of, I can say I can say it's a module. A module. When I say module is I mean you have to you have to turn it into positive, because R is always positive. You'll never find R which is negative. It's always positive. It's always between 0 and the positive infinity. I don't know if there's any question here before we move. Any question about anything? If there's any question, you can ask. Yeah, so basically
For the R,
yes,
for the R, is it okay if you can use raw? Maybe you have to be using R all the time.
Oh, that's a nice question. For the R, no, it's not okay for you to use raw, because right now you're getting 2 angles, and if you have seen, there are 2 radiuses. Yeah, I can say, yeah, there are 2 radius. There's the radius which is O and M, which is the grand M, the big M, which is denoted by R. Then there's also radius which is O and a small m here, which this one is the one which is going to take what? Rho. So basically it's not advisable to where there's R, you use rho, because it's like you have rho, because this is all small m is another radius. It's like the combination of I can say is the combination of the rho, the radius which you have been looking at, the rho, and also the other radius which has now come in, which is the r. So the r is the new radius which has come in, and you always have the radius which is the rho. So for you to understand, I think there's something which had yeah, there was something which I had written in line with that one. Let me just see. Yeah, I don't know if you can see my what my diagram,
Yes.
my sharing. Yeah, so your question was, is R equal to rho? I said no, it's not equal to rho because you have introduced two angles, and if you introduce two angles, it means you have now two radiuses. So there's a radius which I was saying, which is between I forgot to put some variables. Here's O and here's grand M. So this is the R which we were talking about, or M, and there's also radius which is O and a petit m, which is what? Rho. So you have got, I can say you have got two radiuses. You have got two radius, which is R and rho. So you have seen, and I said that this distance here is just the same as the distance from Z here. So you have seen there's rho, then there's a radius, which is what? R. So yeah, so I can say these R and rho, they are just letters which they are just representing what which they are presenting radius. So both of them, they're just presenting radius, but they are not the same. Yeah. So here the R is representing radius, and the rho is representing another radius. Yeah, that's what I can say. I don't know if it's clear.
So radius and the whole, they are not equal.
Radius and what?
The whole.
The rho.
Yes.
I can say if you say radius and the rho, I can say it's like how can I explain it? It's like you're saying the same thing. I'm saying this R here. If you see this R here, if I want, I would have put J. If I want, I would have put K. If I want, I would have put L. So this R here is just a letter which represents what? Radius. This R doesn't mean I can say this R is just it doesn't mean that is how can I say the R is not a symbol for you know it's not a symbol for radius, but it's a letter which presents radius. I don't know if you're getting that one. The R is a letter which represents radius between what? O and M. So here, if I want, I can put K. Yeah, so this the R is the radius, which is a letter which represents the radius between O and what? The capital M. And the rho is also a radius. That's why, yeah, that's what I'm saying. You cannot say radius and rho, because rho is also a radius which is represented by a letter, rho is a letter which represents a radius. I can say so in other terms. So you see that the distance between O and M grand is not equal. So this radius for the letter R is not equal as the radius for the letter rho. I don't know if it's clear now. I don't know if I've explained it clear. If you still have any.
Yes, okay. I have a question. I've understood this part now. Can you explain again the part when finding the formula, when making a formula for finding the vector position of M?
Oh, okay. So when you want to find the formula for vector the position in the OM, first of all, you have to see if I change. The first point which you have to do, you have to know the variables which defines coordinate-spheric. What variables define coordinate-spheric? So we know that the variables which define coordinate-spheric is what? R, theta, and what? Phi. So the first thing is you have to try varying these, I can say these variables one by one if you observe any change. So I say that we're going to start with phi. If phi, the vector if phi, which is, you have seen this distance OM, or is just the same as this distance. So imagine here is J and M. So if I I move this point M here around this circle, which forms the plan equatorial. Yeah, this circle which is on the top horizontal circle. You see that the radius rho doesn't change. It's always the same. The radius rho is always what? The same. Even though my circle is not into scale. But if you see a circle which is drawn into scale, you see that the distance what? Rho doesn't change. It's always what? It's always the same, which means that the phi, since the phi represents the movement of a point around the circle here, you see that the phi to always remain a constant. Yeah, I can say the phi is when how can I say it? When you are moving this point, it's like you are changing this angle here, the phi. But since the distance between J and M is what is constant, it means that your phi is equal to what? To 0. Is the change more. I can say the what since there's no change in what in the radius, it means your phi is always, I can say it's always a constant. A constant meaning if I try to differentiate that phi, it always gives me a 0. So you see that if the radius, what you should know just is that when you're moving around a point around a circle which is horizontal and you see no change in the distance between J and M, we have named this one J, you should know that your phi is what? 0. It's the same thing with your theta here. When you're moving this radius, which is represented by the letter R, when you're moving around the circle, the radial circle, if I repeat, this diagram is not drawn to scale. If it's drawn to scale, you'll see that the R will always have what? The same distance around what? Around this circle at right. So it means what? Since the R is it makes the angle which is theta, you'll be changing theta, and the OM, we are interested not the changing of theta, but we are interested by with the distance OM. So you see that the distance OM is what? Is still the same. When the distance is constant, you have your theta is equal to what? 0. So your theta and your phi is equal to 0. But if you try to move this point outside, for example, into another sphere which is bigger, you see that the distance R changes. So you see that basically there's a change in moving outside what? Outside the sphere into another sphere. You see that there's a change. So you see that for me to find the position OM, I have to use the formula which is R vector ER, which is, yeah, that's the formula which the vector for position, because it's the one which marks a difference. If I try changing it, I see there's a difference, something different happens, like, or I can say the radius OM changes, but you see that if I move a point, basically when you are moving a point around the circles, the radius usually doesn't change. The radius is always the same. I don't know if it's clear.
Yes.
Yeah, so that's it. So we're still on coordinate spheric, and yeah, so we've talked about the vector position. The vector position is OM is equal to RER, which I'm from explaining how to get the vector position, and the relationship between coordinate spheric and Cartesian. This one is not really important. I can say this part is not really important, but we'll just try to build the relationship between the x. You know that coordinate Cartesian is represented by x, y, and z. there are no angles, there are no what. So what does X of coordinate Cartesian correspond to, and what does Y of coordinate Cartesian correspond to, and what does X of coordinate Cartesian correspond to in terms of spheric, and what does Y in coordinate coordinate Cartesian correspond to in coordinate spheric, and what does Z in coordinate Cartesian correspond to in coordinate spheric. So you see that X in coordinate spheric is just the same as R sin theta cos phi. So we're going I'm just going to explain. I think I had already explained, but I'll explain it again how to find R sin theta cos phi. Then Y correspond to, in coordinate spheric, it corresponds to R sin theta sin phi, and Z it corresponds to R cos theta. So how do you find this this correspondence, this relationship between the X, the Y, and the Z? So I'm going to explain this one first. So basically, when we're talking when we are trying to relate or to find the relationship between the X of the coordinate Cartesian and the variables of coordinate spheric, first we have to note some things, I can say so. So here we note that, first of all, what you should note that is that there's a radius which is OM, which is presented by rho, and this radius is just the same as the radius is just the same as the radius. Imagine here, I said here is our JM, just the same. These lines, since my drawing is not to scale, but if my drawing was to scale, this line must be the same as this line, the OM. So you see that this line here is the same as what? This line. And if you remember, under coordinate Cartesian, we said that X, you know how to find X is equal to what? Rho cos. Instead of cos theta, we have used what? Cos phi. Why have you used cos phi? Since we have said that the angles under, like if you check coordinate polaire, coordinate spheric, you see that it's the theta which makes what? A 360 degrees. But here you see that it's the what? The rho which makes the 360 degrees. So the rho here, it is just the same as the theta which you find in coordinate polaire and coordinate what? Cylindric. I think that one I had talked about it. So that's why you have seen here there's a change here. Instead of writing a theta, because we are in a coordinate spheric, they have written cos phi. And I think you know how we come about it. Cos phi. So basically, for example, this is our X, and if you draw a line here, you form a sort of a what? You form a sort of a triangle, and a triangle. After, if you use your Socator, you have the angle here. So this one, the radius, always the radius is what? Hypotenuse. So you see that this is your hypotenuse, and your X is what? Your adjacent, because the angle is touching what? The OM and the OX. So it will be for to have to have hypotenuse and adjacent, you have to use, if you follow the Socator, you know that it's under car, which is cos is equal to adjacent over hypotenuse, and we have said that the adjacent is X and the hypotenuse is what? Rho. So it will be cos phi, which is this angle here, is equal to X over rho. Then if you do your cross multiplication, you find that you have rho cos phi. I think this one is clear. Then for Y is, you have seen your Y is this line. Your Y, if you see here, the line which is parallel is what? Your Y, and this angle is formed here. So it means that this is the hypotenuse and what? The opposite. Imagine there's a line here, which is the opposite. So it will be opposite. So which is sine is equal to opposite over what? Hypotenuse. And the opposite is what? Your Y, and your hypotenuse is what? Rho. Then if you do a cross multiplication, you have rho sin phi. This is where these two formulas, they come, where they come from. So if you have those two formulas now, is the matter of replacing the what, the row and these two row. Is the matter of replacing these two row. And as I said here, I said that the distance here, OM, the petit OM, is equal to the distance JM. Imagine there's the grand JM, this distance. So this distance is 4. So if you see here, it makes a sort of a what? A triangle. With your R, here your R is the one which is your hypotenuse. Yeah, your R is the one which becomes your hypotenuse here. Whereas the angle is made, your R is the one which becomes the hypotenuse. So how do you find it? How do you find the I can say the formula in function of what, or of rho, meaning rho has to be at the subject of the formula. So you see that you know that the angle is formed here. This is the R is hypotenuse, and the rho is what, the opposite, because the angle is what formed here. So it will be you know, hypotenuse and opposite use what, sine. So you know that it will be rho over R. Rho is the opposite over R, which is the hypotenuse, is equal to what, sine what, theta. And if you do your cross multiplication, you have R sine theta. So where there's rho, you just replace by what, R sine theta. So rho I'll place by R sine theta, rho I'll place by R sine theta. So it'll be R sine theta cos phi, R sine theta sine phi. That's where the formula for after you have replaced your rho, and after you have replaced your rho, you find you come up with the formulas which you are from looking. So which you have said that the x correspond to R sine theta cos phi, and the y correspond to R sine theta sine phi in coordinate spheric. Yeah, so this is where the formula comes from. It's just getting the things which we already know, and you just do some replacing. And for Z, for you to find Z, you know that this is Z here. This represents Z here. So this Z is adjacent and hypotenuse. So it will be, you know, adjacent and hypotenuse is car. Yeah, so it will be cos is equal to hypotenuse under adjacent, where adjacent is Z and hypotenuse is R. This is the formula here. Is it cos theta? Then if you do a cross multiplication, it will be Z is equal to R cos theta. That's the relationship where you find between coordinate Cartesian and the coordinate spheric. Yeah, I don't know if it's clear or you have any questions there. So basically, that's where the formulas they come from. Is there anyone with any question? Hello? If you have any question, you can ask. Yeah, but I believe it's clear. But if you have any question, you can ask me. You can ask me so that when is there anyone with Mafu? So if you have any question, you can ask me. Yeah, so if there's no questions, and the relationship entre, so this one, the one important thing is knowing how to come up with what, the x, the y, and the z. What's relationship between the x of coordinate Cartesian and the coordinate spheric, the y of coordinate Cartesian and coordinate spheric, and the z of coordinate Cartesian and the coordinate spheric. Then these yes, you have.
Sharing a screen.
You can see my screen?
No.
And it's also not recording.
No, it's a bit. It was. Yeah, just wait a bit. Yeah, it has started recording. Can you see my screen now?
Yeah, it's sharing.
Sharing, okay. Is it still sharing? Hello?
Yeah, it's in the process of sharing, but it doesn't yet show this the screen.
Like the connection is a bit.
Okay, it's now sharing.
It's now sharing. Okay. Yeah, so basically, like, yeah, these down formulas. They are not. I can say they are not really important. Yeah. So basically, yeah, for you to have your UR, you just know that you just remove the R, then you just write the same sign. Yeah, for X. This one represent X, so just write the sine theta cos phi, then vector I plus C, then your Y is C, sine theta, sine phi J, and your Z is just what cos theta, which you have already found. So if you just know your UR, then you can just now start to play with the differentiation, all those things. So basically, they don't usually ask a lot of questions. Give us the relationship between cordon spheric and cordon Cartesian. Yeah. So these things are not. I can say these formulas here, they're not really important. Yeah. So but you can due to time or not, I think I had to explain that day, but due to time I just yeah just try to see through these formulas. And here you should also know that when I say differentiation partial of UR, partial differentiation of UR divided by d what this one is d theta, this one is d theta. So meaning I have to differentiate my UR, which is UR in terms of what theta. So it means cos phi, these sine phi, these are constant. So I'll be on I'll be on what differentiating my what my sine theta. Yeah, I'll be only differentiating those which have got theta, which is sine theta, and what cos theta. And if you differentiate sine theta, if you remember that diagram which I gave you, if you differentiate sine theta, it gives you what cos theta. And if you it will differentiate sine theta, you have seen that the cos phi here, it remains the same, but only the sine theta, it changes to what cos theta. And also the sine theta here changes to cos theta. And if you differentiate the cos theta, it will give you the negative sine what theta. You should check a circle. I gave you a circle how it should move when you are differentiating. So when this down here, when I say d theta, meaning I differentiate according to what to theta. I differentiate according to theta. And if we then the other one remains what a constant. And then this one is d what this one is d d theta. This one is d theta divided by differentiating a partial differentiation of d theta. So here it means I go where there's u theta is this one, then I differentiate it in terms of what d theta. So I differentiate this one in terms of d theta, meaning I want to differentiate the cos theta and the what negative sin theta. So if you try differentiating this one, you and the answer which you find, you multiply it by negative, it will take you back to what to this UR. It will take you back to what you are. If you multiply it by what negative. So you should know how to differentiate. This one they are saying you differentiate in terms of what of phi. When you differentiate in terms of phi, meaning this cos theta here is a constant, and when you differentiate a constant, it will give you what is 0. So you won't remain. That's why you see that you won't remain with 2. So you should just try when you're home, like when you're passing through, try doing some differentiation, and you see that these answers, they'll be coming out. So if you just know one, you can answer almost everything. I don't know if there's any question here. Is there any question? So basically here you don't really need to waste a lot of time. Is there any question here? Is there anyone with any question? So There's no one. We're going to continue. So we're going to now look at the déplacement élémentaire. Déplacement élémentaire basically is moving from one point to another, the movement of M from one point to M to M prime. So when you're talking about déplacement, it's moving from M to M prime. So what happens when you move from M to M prime? What happens? So you have to know what usually happens when you do the movement. So when you do the movement, the first thing which you do, I hope you can see my sharing. This one you have to follow because it's important. Are you seeing my sharing?
Yes.
Okay. So this is we are starting. This is the point where we're starting on M, the grand M here. This is the point. I want you to follow me. Yeah, this is the point which you are starting, the grand M here. And we want to reach this point. So for you to reach this point, there are movements which you have to follow. There are some movements which you have to follow. So you have this point M here. Then for you to move to M prime, first of all, you have to move lateral. It means you have to move under the what the I can say you have to move on the what on the lateral circle, which is the circle which is the side circle, not the one which is on top. Since we have seen that the basically they are formed by a small circle on top and a circle which is the side circle. So the first thing is you have to move what in the side circle, which is the sorry, I lost my connection. I hope you can see my sharing.
Yes, we can see.
Okay. So I was saying that the first movement which you move is the movement. Since you said that there's two circles, there's a horizontal circle which is under the which is uh, uh, the equatorial plane, which is the small circle on top, and there's also what a circle which is formed, I can say, in sideways, or the lateral circle which formed the meridian plane. I can say so, meridian plane. So the first movement, what you should know that you see the movement of the circle which is in sideways, the circle which is the sideways circle, and this movement, if you see here, the movement you have the change in what in theta. You move the point M will move to this point, another point here. Yeah, this new point here, and this you see that there's a change of what of theta, but you see that we have said that when you're moving the radius or M, the R doesn't change. So that's why you're seeing that R is constant. What changes on is what theta, which is d theta, which you have seen there's a change in what d theta. Then from there you are here, you move like you are moving what you move like you are moving around you are moving around like you are making an arc. Yeah, if you move this is a point here, you move I think you yeah, you understand better if I use if I use the top part, because it's just the same thing. If I use the top part, you understand better. So the top part you have A and the B, so you have M, A, B, and the M prime. Yeah, I'll re-explain it, but I'll use where they are letters so that you understand it better. So you have got what? M, A, B. Yeah. So here basically for them, they have started with the small circle, which is on top. So you can start anywhere you want, whether with the side circle or the small circle. So here I'm going to start with it. Since I want you to understand, so so I'll follow with the letters. So with the letters, what they have started is they have started with what? The small circle. So if they move from, first of all, you move from what? M to R, which is, if you see here, it's like an arc. You are forming the arc, like Pamwamba, like you're forming an arc, Pamwamba, on the top. You're forming an arc on, yeah, you're forming an arc, which is a point is following the smaller circle, which is on the top. And we said that the smaller circle is defined by, if you remember, I said the small circle is defined by what? A phi. A small circle is defined by a phi because the point here, OM, the point here, which is, I can say, you have said that the distance between O and M, there's rho here, and also there's rho between ZD and the capital M. So meaning when I'm moving here, the rho doesn't change. What is changing is what is the phi. So if you see here, just the same here, they have represented, that's what I've seen here down, they have represented something like an arc. This is the movement of M, which makes what? An arc to point what? To point I. It's like it's moving around what? A circle. So yeah, so the circle which is on top here is the same circle which is down here. That's why you have seen they have projected here down here. So you make the change more. So you see that what changes here is the phi. That's what I've seen, d phi, and the what changes here is what? The phi, which that's what I've seen, what? D phi, and you have seen that the rho is always the same. If a point is moving around the circle, any circle, the radius is always what? The same. So you see that the radius is the same, and this radius is represented by rho. And we say that after, when we are finding rho, we say that rho, we found what rho is equal to. So we said that rho is equal to r sine theta. Wherever, if you remember, where we are replacing what? We're replacing rho by r sine theta, r sine theta, r sine theta. So we found that your rho is equal to r sine theta. That's why you have seen that instead of writing rho here, they have just written what? R sine theta. Then with the changing of what? D phi, which is here the changing. So this is from moving from point M to R. Then from R, it moves what? To B, which are the explained area. When you're moving from R to B, it means what changes here is you see that the distance R, the distance, yeah, the distance R actually doesn't change. The distance, if you draw the distance from O to this point R here, the distance from O to this point R here, and when you try to move around the side circle, see that the distance between O and R never changes. And what always changes what? The theta. So you see that there's a d theta, which is in change, but the radius r, which is what? Constant. That's why you're saying there's r d theta. This is where the r d theta is coming from. Then from there, you go outside the sphere to the point M, where you see that there's the change more of what? The radius. Yeah, the r radius. So you see that the dr is what? Is in change more. So you see that for you to calculate the mm prime, you have to change the dr er, which is the movement, towards m prime, yeah, following the vector er, plus the r d theta, which is the movement around the circle, which is what? The lateral circle, the circle which is sideways, which follows the distance e theta, the direction e theta, plus r sin theta. This is just the rho. We have replaced rho by r sin theta times d phi. D phi is the angle which is made when you are moving from M to R. This arc which is made. So this is the formula for you to find what? The displacement M prime. I don't know if there's any questions where I didn't understand.
I didn't understand.
Okay. So
I've got
yeah.
a question
So
too.
you mean everything?
No. I've got a question. How is B to M equal to R sine theta delta phi.
R sine theta.
Delta phi. Yeah, how is it equal to Bm prime?
Okay. Yeah, I think it had let me just go back to my video, to my previous picture. Can you see my picture, my sharing? Can you see my sharing? I've changed. I've gone to the PDF, to the what, to the thing where I did the drawing. Can you see my drawing?
Yeah.
Yes.
Okay. So the question is, where does R sine theta comes from? So as we said earlier, we said that this distance, it represents rho, which is the same as this distance, which is rho also. So basically, when you are moving a point, so now we want to find the mm prime. When you are moving a point around this circle, which is lateral, you see that the phi is changing, which is the d phi, but the radius, the rho, is always the same, which is, yeah, the radius, the sorry, I've made the mistake. Yeah, for the rho is for the circle which goes round. Yeah, yeah, I mean, so when I'm talking about, imagine here there's a circle which is going around. Yeah, because my drawing is not onto scale. The circle which is like the same circle which, like the one which is on top here. Imagine there's a circle which is going around. Yeah, which is the same as the one which is on top here. So you see that when this point, it's just the same if I use the point on top, the circle on top, or the circle, the imaginary circle which is down. So the best thing is I'll use the circle which is on top here, the small circle which is on top here. So when you're moving this point here, and this angle here is just the same as the angle which is here. So this is phi, this is also what, phi. So yeah, so since they have got the same radius, meaning this angle here is just the same. Yeah. So what happens is, when I'm moving this point here, the hole, when I'm moving it, you see that the distance between, I'll call this one J and M doesn't change, which is rho, but what changes is what is the phi, the d phi, because the angle is always in constant change, but the radius is what is the same. So you see that the radius is the same, which is rho, and the one which is changing is what, d phi. So that's why you're saying you have something like rho d phi. Rho d phi. Then where does the r sin theta comes in now? So the r sin theta is making phi the subject of the formula, replacing phi by r sin theta. How do you replace phi by r sin theta? So since we have said that this distance, OM, is equal to this distance which is on top here, yeah, which is rho. So you see that you make a sort of what, a triangle here with this angle which is what, theta. So this r is your hypotenuse. This r, the r which is here, it becomes your hypotenuse. Then this one definitely becomes what, your opposite, because your angle is touching between line Z and line what, r. So this one becomes opposite. So for you to find for you to express rho in terms of r sin theta, you know that your rho is your opposite, which we have said here. Your rho is your opposite, and your r is your hypotenuse. So when you do your cross multiplication, you find that your rho is equal to r sin theta. And you say that when the point is moving, only the phi changes. So it will be rho times d phi. So the rho is replace it, and you have known how to find it. It will give you what, r sin theta d phi. So this is where the r sin theta is coming from. Don't know if it's clear.
Yeah, it's clear. But I wanted to know how is it equal to Bm prime?
How do what?
How is it equal to Bm prime? When you go to the previous diagram.
Or the m prime?
No, when you go to the previous diagram, there is B to M prime.
Just wait. Can you see my sharing? Can you see my the one for our lesson, the sharing?
No.
It's still sharing what?
Okay, I can see it.
You can see it? Yeah, so you're saying what?
I was saying on the displacement elemental, you're saying it's equals to m prime, m to a prime plus ab plus bm prime, right?
Yeah.
Yes.
So the
Now
displacement?
when replacing there on bm prime of both r's and theta d phi, how did that come about? How is it equal to that?
Oh, okay. So you have bm prime. No, they have made the mistake. bm prime, yes, so the one who was writing this book had made the mistake. So if you see here the way it is, that's a good observation. So there's actually they have like basically, I can say basically the DR most of the time they have just rearranged in such a way that they haven't really followed the way it is. Yeah, I hope you can see my screen so that I continue.
Not yet.
Can you see it?
Sharing.
Sharing. Is still writing sharing or what?
Yes.
What of now?
It's sharing. We can see like it's there.
Is it still, I think the network is bad. Is it still sharing? Yeah, can you see my sharing now? Hello?
Yes, we can.
Okay. So there was a question which was posed. Yeah, so the way they have written it here, down here, they haven't really followed the order. Yeah, but the displacement, the displacement, everything is correct, but they haven't really followed the order, the way they've written it down here. So yeah, that's a good observation. So you see that when you move from M to R, it's like you are making an arc. arc, this arc, which is I can say a horizontal arc, which is the one which forms the one which forms the small circle. Since I said the small circle which is on top and the small circle which is down is just the same. That's what you should note. On top and down is just the same. So it forms a small circle. So we see here that the M and the M, when you move to M, when you move from M to R, you you form a sort of an arc, and you see that you only change the what, the d phi. The angle, the phi is the one which changes, which is the differentiation, phi. So you only change the angle phi, but the radius, which is the O, the what, the O, this one is small m, the O small m is always what, the same, and this radius is represented by rho. So it's just the same as what, rho d phi. So the rho, we say that is equal to r sine theta. We have seen how to find r sine theta. So this is the movement of what, mr. So mr basically it's supposed to be what, r sin theta, which is they've written it this one is for what, for phi. So they have just done, they have basically they have just what, they have just swapped. Yeah, they haven't followed the order, I can say. So they haven't followed the order. So you have seen that the r sin theta d phi is equals to, which is in the last part. Then from there you move from r to b. R to b is you see here that when you're moving r to b is the distance between O and R, the distance O and R, and you see that this distance is marked by an angle which is what, theta. So you see that when I move from R to B, the theta is the one which is changing, but the radius R doesn't change. That's why you're saying what, R d theta, R d theta. So for AB they have followed quite all right. R d theta, which is what, AB, which is defined by a vector E theta. Then from there, you have to move from what, B to point M prime. B to point M prime, we are just changing the what, the radius, which is what, dr, which is the dr, which is on face. So they have just swapped mr and bm prime. That's where they have swapped, but they move more like everything it's just correct. Yeah, the move more, everything is just correct for them. They have yeah, they have what, they have just put the dr on first, then the r sin theta go last. So I don't know if it's clear.
Yeah, it's okay.
Yeah, it's okay. Then I don't know if there's anyone who has any questions here. So now we're,
is there a day when when we have TD?
Yeah,
or
yes.
it's just learning throughout?
I can't get you saying.
Is there a day that we're going to like leave it for TD, or we'll just be learning throughout?
I guess I gave you guys TD.
No, like TD, like everything like to do with you, or it's just personal? Like
Yeah,
you just be doing it alone?
TD basically, we were supposed to have, we were supposed to be having TDs together, but I don't really like, there's not really time for us to do the TDs, the what, but I'll see what I'll do.
Okay.
Maybe I can find another alternative where I'll just be recording while I'm solving some things, maybe some examples, some exercises which I've given you. But basically, we were supposed to be having some TDs, but due to time, it's impossible for us to incorporate TDs and quiz at the same
Oh
time.
yes, you can do that where you're alone and then you record like some questions and you solve it and then you just send the group. Then ask that one to watch, we'll download and watch.
Oh, okay. Yeah, I think that's the only one which can work. So yeah, so I'll do some yeah, if I give you an exercise, the correction which I'll be sending in form of I'll be doing a video. I explain how to solve all that. Then I'll be sending it to the group. Then I think that way it can be better. Yeah. So is there anyone with any question? So if there's no one, so now we're going to surface elemental. So for surface elemental, you don't really need to panic. Which one should I like? How should I calculate the surface? What you should only know is you should know which part is constant. Yeah, most of the time they specify in questions when they tell you to calculate surface, you can't you can't use three variables, because when you use all the three variables, it's like you're calculating the volume. So basically, you'll be using two variables. So which variables are you supposed to use? Is it r, theta, phi? It will be the question will guide you. So most of the time is the question is the one which will be what guiding you when finding what the surface. So if they tell you to find the surface, they tell you to find the surface where the phi is constant. Yeah, they ask you to find the surface where the phi is constant. Meaning, when they say phi is constant, meaning when you go to your equation here, where d phi here, when you differentiate the d phi here, it's supposed to give you 0, and you know that when you multiply 0 with it, all this is 0. So you want to remain with it, r d theta and the dr. So you should for the surface area, the thing which you should know is the thing which you should know is the the formula of the mm prime. If you know the formula of mm prime, you know your that there's dr, r d theta, and r sin theta d phi. You know that each time they specify a constant, you know that one of them has to be 0. For example, if I say the radius, the r is constant, most of the time when they say rayon r, it means r is like they're just saying that r is constant. You know that when your r is constant, your dr is 0, so you only work with r d theta times r c theta d phi, and the times the vector which where it I can say where it yeah, for this one there's not even a need of putting a vector. So yeah, so that's how it is. So here they're saying phi is constant. So when phi is constant, it means the differentiation phi here, when you differentiate phi here, it will give you 0. And when you multiply this whole thing here is 0. So you only have dr times r d theta, which is here. If you check here, is dr times the r d theta. And I said that when you are finding the surface, the volume, you have to group the like terms together. So those which presents the same things in other words. So you see that you have r dr. So when you start doing your integration, your what, you see that you have your r dr, the integral r dr times the integral d theta. Yeah, if you pass if you pass through how can I say, if they ask you to find the surface area of something where phi is constant. So here in terms of a diagram, to present it in terms of a diagram, it just means that in terms of a diagram, it just means that for example, if you have a point M here, you can't move under this arc, which is the r sin theta d phi, since the phi is the phi is constant. So mean the phi is always constant. So you cannot move from M to this point, which we call R. You just move from M direct to to B. So you see that you move from M to B, and from B to this point here, which is, we can call it K prime, or we can call it K. So you move M to B and K. So you see that it's only defined by r d theta, where you see you are changing the theta, but the r remains constant, times the dr, where you're moving outside with what? Phi is constant. I don't know if you have any question under phi is constant. So basically, what you should know just is that when phi is constant, d phi, the differentiation under the equation mm prime is equal the d phi, the differentiation phi is equal to 0. So only remain with 2. If you know those, you don't even need the diagram to explain all those things. Yeah, you know, because most of the time they give you a hint and they tell you that this one is constant or that one is constant. So if theta is constant, it means what? The d theta is what? Is constant. So if theta is constant, it means you have the d theta which is constant, meaning the value which is in between here supposed to give you 0. The value which is what? In between here. Since d theta is constant, when you differentiate the constant is 0 times r, 0 times r is 0. So you only have dr times r sin theta d phi, which is the equation which you have here. Dr, if you check here, if theta is constant, you have dr times r sin theta d phi, because d theta is the r d theta is equal to what? Is equal to, I can say the r d theta is equal to 0. Yeah, I can say the d theta here is equal to 0. So this whole what here is equal to 0. So meaning I cannot move around like around the arc, which is what? Which is the sideway arc. I cannot move in the sideway arc. Again, the M can only move direct to R. When it moves to R, then it moves direct to what? To, I can call this one, or maybe M. No, I'll call it what? I'll call it maybe S. So you move M to R, then direct to S. That's why you're seeing that they have shaded. It's just the same thing even here or down or even on top. So you just shade the upper part. So they only want the surface area, which is here. Yeah, the upper part, the surface area, and the R d theta is what? Is 0. So that's how you are supposed to go about it. So basically they tell you which one is constant. So if you know which one is constant, you know which formula you have to use for you to find the surface of a certain shape, of a certain sphere, I can say of a certain sphere, yeah, of a certain sphere, and yeah, that's what I can say. So I don't know if there's any questions. Any questions before we move on? So R constant is also the same thing also. So this one, when you're finding the surface element, as R constant is also the same thing here. So it means that your dr, yeah, you should note that that is only the R is constant, which means what? Which means that only the differentiation of R is the one which gives you 0. Because if you check your equation here, you have, if you check your formula here, you have R, then dr. The R here is constant, the R here is constant, so it's not affected. The only thing which is affected is what? The dr. When you differentiate the constant, it will give you what? A 0. So you see that hello, can you get me?
Yes.
Yeah, that's happened like this. Just wait a bit. Some problems with my PC. Yeah, I'm having, but you can see my sharing.
Oui.
Yes.
Oh, okay. Yeah, so yeah, so like I was saying, your dr here is a constant, meaning if I differentiate my dr, it will give me 0. So I will only remain with r d theta, r sin theta, d phi. So you see here that when R is constant, you have this formula, which is which is R d theta times R sin theta d phi, and we say that the like terms you group them together, which is d theta sin theta will be grouped together. Then the R times the R will be R squared. Yeah, the R also will be grouped together. Then the d phi. So we say that the theta moves pi 0 to pi, which is 180, and the phi moves 360, which is 0 to 2 pi. So yeah, so these are the formulas which you play with, I can say. So when you have been asked to find the surface area of a sphere when the phi is constant, or when the theta is constant, or when the r, which is the radius, is constant. These are the formulas which you basically use. I don't know if it's clear.
So the O is still the variable which is constant in the question.
Yeah, they'll always tell you that this one is constant. Yeah, they always specify.
All right.
Yeah. So then for R like the radius R, they just say if you have been given a question where they have told you to use coordinates, they have told you that the form is a sphere with the radian meaning radius R, meaning they are specifying that the radius is constant. So most of the time, they can tell you that R is constant, or they just write radian R, which means it's constant. Yeah. But for these others, like the phi and the theta, they always specify that this is the theta is constant, the phi is constant. Yeah. And for the volume, volume is not something which is really difficult. The volume is just you just get the whole formula here, which is the dr d theta plus r sin theta d phi. Then you just multiply everything. This is the formula here. If you see they have multiplied everything, where you see that there's r, which will give you r squared. Then there's sin theta, dr, d theta, and the d phi. Then you try to if you check your side here, you see that you see that you have the formula of dt. Basically in what when you see a symbol which is in a sort of like a catif, you know that it represents what volume most of the time. That's what here, like I can say here in Morocco, that's what they use. They don't use dv what they some they use the dv what, but most of the time when they're representing volume, they write something like a symbol which looks like a catif. So if you see here, this is the formula for volume. So volume elemental, which is dt is equal to r squared times sin theta dr times d theta times d phi. So this is the formula for you to find what the volume. So yeah, so if they have asked you to find the volume, that's the formula. That's the formula which you have to play with. I don't know if there's any question. Is there any question? Any question before we? Yeah, we are done. We are done for the first chapter. Mafunso. Is there anyone with any question? So yeah, I'm seeing time is not with us. Yes, I could time up. So next on Wednesday we're going to start a new chapter, and that chapter, believe me, we're going to finish it because it's something which is really simple, which is you have already done it. So we're going to my aim is on Wednesday we have to finish the next chapter which we're going to start. Yeah, we'll have to finish it. Yeah, we're going to talk about in a nutshell, we're going to talk about electricity and how did the electricity come about, and we're also going to talk about charges, forces, those things. So yeah, so the history, I'll just pass very fast under the history because
So, sorry,
it's not really important.
sorry.
You have a
You're
question?
asking if they, yeah, you're asking if there is any question.
Yeah, I was asking if there's any question before we
Oh, but
wrap up.
it's not on Codones Feric. I just wanted
Uh-huh.
to ask if you can please explain a bit on Codones cylindric on the area and the volume.
On the how to find the area and the volume.
Yes, yes, yes. Just a bit,
Oh, okay.
since we are concluding.
Let's go to the flow. Go to the cylindric. Yeah, so under Codones cylindric, yeah, under Codones cylindric, you see that for you to find your displacement OM, you have unfortunately my word can't move. No, yeah, so for under coordinate as cylindric, you see that for you to find the displacement, you have this formula. If you see on the right side, you see that you have the formula which is d rho plus rho d theta plus dz. And I think you know how we found this. For you to move from point M to point D, M prime, you see that first of all, if you my pointer can't move, so just right now I'm talking at the diagram. Just be observing the diagram. So you see that for you to have the point M prime, you have to move first the theta, which is the d theta. Then you move like you're moving outside, which is you are changing the d rho, and you move up for you to have what the M prime. So see where this formula is coming from. So when you have been asked to find the surface elemental, the question which you are asking. So for you to find the surface, basically they will tell you which one is what is constant. For example, surface lateral, which they have told you that rayonnement rho, which means that rho is what constant. Rayonnement rho is constant. So when rayonnement rho is constant for surface lateral, you should know that your formula here, what you should just know is that to a formula here, d rho is equal to 0. So you are just going to remain with rho times d rho, rho times d theta plus rho times d theta times dz. That's what you are going to remain with, which is here. If you check, if you check at your left side, you have this formula which is rho times d theta times dz. Left side, when you check your left side, times what rho. So you see here that they have said that the radius is what the constant. Even for this one, they specify which one is constant. So if they say radius is constant, it means you cannot move